Yep.
So this is joint work with Scott Carroll, David Figlio, and Lester. Lester actually is right here. So he's going to be able to answer some of your question in the chat. I'll keep an eye also on the chat. Let's get to it. I really want to spend to keep a good 10 minutes to answer your questions. I've been working on publication bias p-hacking for 8 years now. And I've been desperately trying to write this paper. So it's very exciting for me to be able to finally show you some graphs that I've been trying to, to compute for years now. So we're interested in publication bias in economics, but really the goal of the paper is to try to understand the role of authors, of reviewers, and editors. So we know a lot about the extent of publication bias, the extent of p-hacking in the social sciences, but there's not much we know about what's actually happening once a paper is submitted. We know a lot about papers that are published. There's a lot of studies that have looked at these papers and documented, for instance, the distribution of test statistics in these for these published papers, but we don't know much about papers that are rejected. And here, what we're going to try to do is to look actually at the distribution of test statistics for papers that are rejected. Some of them are rejected, some of them are rejected, and some of them are going to be accepted. And we're going to be trying to understand at which stage do we see a change in the distribution of tests. Is it that reviewers are the ones that really like statistical significance, or is it editors? Or is it the authors themselves that, in reaction to a belief that people really like stars, are going to be doing a lot of specification searching? So because of the nature of this project, we're going to be able to shed some light on this. And to my knowledge, there's really only one other paper that has managed to do a bit of that, and it's Franco and co-authors. This is a well-known paper. It's been published a couple of years ago. It's my favorite paper that has been written on publication bias over the past 10 years. They do not have data for a journal, but they do have papers that they follow over time. Some of them are submitted, some of them are not submitted, but they all receive a grant. Whereas here, what we're going to be able to do is to look at papers that are actually submitted to an academic journal, and we're going to have the status. We're going to know whether they were rejected or accepted. So this is how we're going to be able to unpack the role of authors, editors, and reviewers. So the journal in question is the Journal of Human Resources. This is a top field. This is an economic journal. This is not one of the top 5, but this is the journal you would go after, unfortunately, being rejected at the top 5. So this is a really good journal. The acceptance rate is 6%. They receive hundreds and hundreds and hundreds of submissions every year. This is a really, really good journal. A third of submissions are being rejected at that journal. So what we're going to do, we're going to look at the JHR. We're going to look at submissions to that journal for the years 2013 to 2018. And we're going to randomly select papers. We're going to restrict the analysis to only papers that use a method to get a causal effect. So a difference in difference, an instrumental variable, a randomized control trial, or a regression discontinuity design. So basically they're interested, all these manuscripts, in getting a causal effect, the effect of X on Y. And we're going to randomly choose some papers, and we end up with 400 papers submitted to that journal. We're going to, not me, but we're going to manage to find a way to get all the test statistics from that paper, from all these papers, and we're going to keep only the coefficient of interest. The coefficient for instance, if it's a difference in differences, it would be the interaction term. If it's an IV, it would be the second stage. So that's the coefficient of interest. We're going to discard all the control variables, all the subsample analysis, all the constant. We're only going to focus on the coefficient of interest. And we're going to be interested in what's the distribution of tests for these different stages. The first stage is the editor's decision. Does he reject or he sends to reviewers? So we're going to be looking at the distribution of tests at that stage. Then we're going to move to the reviewer stage. For papers that are not rejected, we're going to look at, did the reviewers like it versus they did not? Did they really love it, or they just said weak R&R? And we're going to be comparing these different decisions, we're going to be looking at the distribution of tests. Then we're going to move to the last stage. Some papers got accepted. I mean, they do accept some papers at that journal. And we're going to be comparing from the initial submission to the final published version that you and I can actually see when we go on JHR's webpage. The other thing that we're going to be interested in doing, and we're doing it right now, is to track the rejected studies and to see, did they end up being published elsewhere within say 5 or 10 years after being submitted to JHR. We haven't done this, but this is on the to-do list. And we're also going to be conducting a survey on researchers' behaviors. We're going to be doing the survey probably in February, March. So I'll show you the question, and feedback would be really great here. Okay, so before I show you the results, let me show you what the distribution of test statistics in economics usually looks like. But that's only for published papers. That's top 25, according to REPEC. So it's top 25 journals, and it's hundreds of papers. And this is a graph taken from another of my study published in AAR recently. And what you see is the distribution of these statistics. So in economics, we do not always report p-values or confidence intervals, unfortunately. So we get the coefficient divided by standard errors, and we get a z-stat. And here I'm showing you the distribution from 0 to 10. And what you see is it looks like 2M shape. There's some missing test statistic close to 1.5, and there's a surplus. There's too many, if you will, close to the significance threshold. So let's say close to 1.96. So you could say that potentially there's a bit of p-hacking happening in economics. If I would show you this for sociology or political science or other disciplines, social sciences, it's much more. In economics, there's p-hacking happening, but it's definitely not to the extent of other social sciences, which I guess is good news for us. But there's still probably a bit of p-hacking happening. There's tons of methods to measure p-hacking that have been developed in economics. Can have a look at the other paper if you're interested in knowing how we do this. But that's the graph that we find for published studies. Now I'm going to show you in the next 4 slides what we find for papers that are rejected and accepted at JHR. Let's get to it. This is the initial submissions for all the papers submitted at JHR, accepted or rejected. And it looks extremely similar to what you find for published studies in top journals in economics. It's incredibly similar. And this is the combination of rejected and accepted. Now, let me show you what's happening at the different stages. But here, this slide is key. It shows you that there's probably a lot happening prior to submission to JHR, maybe prior to submission to any journals at all. But what we know is the distribution of test statistics before. So when you submit to JHR, the initial submission, it looks a lot like published studies, which tells you a lot about publication bias right away. But let's get to more details now. This is at the editor stage when they receive the manuscript. Is it going to be DES rejected? This is on the left-hand side of this slide. Or is it going to be not DES rejected on the right-hand side? Not DES rejected includes rejected by reviewers or accepted. And here what you see is when it's DES rejected, there's much more of a spike close to 1.96, 1.65. Editors are actually sniffing out papers that are marginally statistically significant. So papers with statistically significant estimates that are borderline significant, editors don't seem to like them too much. So editors are actually, if something, making the distribution of test statistics being less significant. I'm going to show you later that if you control for the quality of the study by authors and article characteristics, you explain a bit of this pattern. So they're sniffing out also papers that are arguably of lower quality, and these papers tend to marginally reject the null hypothesis. But still, even when you add all these controls, there's some evidence that editors are actually still not that interested in significant results, borderline significant results. Let's move to reviewer. There's 3 different possibilities in terms of recommendation by a reviewer. There's, I don't like it, reject. Then there's weak R&R, and then there's strong R&R. Strong R&R is on the next slide. Here, let me show you, so it's reviewers who recommend rejection. It's on the left-hand side. On the right-hand side is weak R&R. Not that much of a difference. Let's get to strong R&R. Strong R&R is the reviewer loves the paper. He loves the initial submission. And there's a lot of stars there. Reviewers do like a lot statistically significant results that are borderline significant. So the reviewers and the editors are sort of canceling each other. But obviously the reviewers are doing it on a subsample of articles, those that pass this rejection. But still, they're canceling each other, which is fascinating. At least to me, it's fascinating. I never expected this. Let's move to papers that are actually accepted. From the initial to the published version. We'll show you when you start including controls during regression, there's not much here. These papers don't change that much. So papers that are going to be accepted from the beginning to the end of the process, I mean, they add some tests, robustness checks, etc., but there's really not much happening here. If something, maybe they're a bit less statistically significant, but overall, we don't find much. Okay, let me show you a bit more formal analysis, but it's going to just confirm everything I've said before. So what's happening is editors are sniffing out significant tests, reviewers like significant tests, and overall, not much. So published papers versus those rejected have very similar distribution of test statistics at JHR. There's many different ways to measure publication bias, p-hacking. We use many different methods in the paper. I'm going to show you quickly Caliper Tests. Caliper Test is not great. There's tons of problems with it, but you can control for co-editor fixed effects. You can control for authors and articles characteristics. So that's interesting for that, but it has some problems. We also do excess statistics. We also do calibration. We do tons of different things in the paper, but let me focus on Caliper Tests. A Caliper test basically is you restrict a sample close to a statistical significance threshold. So you compare the mass of tests that are borderline insignificant versus the mass of tests that are borderline significant. And you run a probit or logit. So the dependent variable is whether it's significant or not, at say the 10% level. And you restrict the sample close to it, close to, a bit above and below the statistical threshold. So let me show you 10%. I'll show you desk rejection, then the stage of reviewer, and then the final stage, which is for papers that are accepted. So this is for desk rejection at the 10% level. The first column tells you that papers that are desk rejected are 9 percentage points more likely to have a statistical significant test at the 10% level. This is huge. This is a lot. The baseline is like 50%. So 50% of the tests in the papers that we have reject the null hypothesis in economics in this specific sample. But there's an increase of 9 percentage points if it's desk rejected. So editors really don't like statistical significance. That is borderline significant. If you put co-editor fixed effects, actually it makes the effect larger. That's the second column. We have 25 co-editors here. So it's not the decision of 2 or 3 individuals. That's a lot of people. And I'll come back to it later. Then you can control for the method use. Is it diff and diff, IV, etc. Column number 4, we're including lots of controls. Authors of the characteristics of the authors. Did they publish in JHR before? Are they tenured? Are they from a top institution? Where did they graduate? Their experience, solo authorship of the paper, etc. And if you include all these variables, which is kind of the quality of the paper, you see the coefficient goes down. So part of the effect of the editors is they're sniffing out also papers of lower quality, arguably. Of course, we cannot measure the quality of a paper. So here we're trying to do that. We're trying to proxy by including as much variables as we can from the author's CV. You can make the window tighter. This is what we do in column 5 and 6. The results are very similar. This is reviewer rejected. Again, there's 3 categories. There's reject, which is omitted. They also can recommend weak positive, or they can recommend a strong R&R. And here what you see is at the 10% level, if it's a strong R&R, you find that there's a positive effect. So reviewers seem to be more interested in papers that marginally reject the null hypothesis. That's what these positive coefficient means. And once you start controlling for authors' characteristics, but also reviewers' characteristics, the same characteristics, but for the reviewers, you find a significant effect for strong R&R, and it's 0.9, so it's 9.8 percentage points. Again, a really large effect. You can change the windows, etc., but it doesn't really change its results. So they're really canceling each other, the co-editors and the reviewers. Comparing accepted papers from the beginning to the end of the process, there's really not much happening. The distribution of tests doesn't really change while you go through answering the referee reports and everything. It doesn't really change the significance of the point estimates. Okay, summary of the findings. We find that actually there's bunching for papers that are submitted to JHR. So there's something happening before submitting to JHR. The authors think that, oh, their journals love stars. We have to report something statistically significant, and they might change their behavior. Do they do this before submitting to JHR, before submitting to any journals? Do they scrap papers that don't find an effect? Could be, but there's something happening before submission to JHR. So what we're going to be doing here is a survey trying to get more information. I'll come back to this in a minute. Then at the stage of the editors, as I said, they filter out marginally significant results. The reviewers do the opposite. And overall, there's not much going on. Now the question is then, what's happening before submission, but also what's happening after submission? These papers that are rejected, do they end up published somewhere? And papers that don't reject the null hypothesis, are they less likely to end up published in other journals, let's say lower ranked journals? So this is something which we're doing right now, trying to track these manuscripts. Because if they all end up published anyway, then there's really not much publication bias at all. But there's a belief that there's a lot of publication bias, which affects the behavior of researchers. But actually, based on this journal, we don't find much here. Okay, the other thing is we're doing a survey right now, and I would be very interested in getting your feedback on that survey. I'm going to show you the questions. The survey, we're not sure whether we'll do a surveys of people who submitted to JHR or submitting overall to top economists, applied microeconomists, or just to a pool of applied microeconomists. So we're kind of settling on a pool of applied microeconomists and asking them question about their submission history, a question about the research practices. But the survey is going to be completely anonymous. So there's no way we're going to be able to say, hey, that person submitted that journal, or it's this individual from a top institution, he answered this, or etc. It's going to be completely anonymous. So we have no idea who's going to be answering this survey or the type of answers they're going to be providing. And here are the type of question we're interested in asking in addition to their submission history. We're going to be asking questions such as, within the past 5 years, for a given submission, not necessarily to JHR, but for a given submission, have you ever reported only a subset of the dependent variables explored during the analysis? Have you ever reported only a subset of the analysis or experiments that you conducted? Have you ever modified the original hypothesis to better match your empirical results? Have you ever excluded or recategorized the data after looking at the effect? Have you ever selected regressors after looking at results? And one additional question that we're thinking of asking is, within the past 5 years, have you ever stopped a research study or refrained from submitting a paper to a journal after finding null results? And that question is really what we're deeply interested in, because we want to know what's happening prior to submitting to JHR. And if we find that there's a lot of people doing this, then the problem is this. It's going to be that people have a strong belief that editors and reviewers love statistical significance. But it seems that overall, there's not that much going on. I mean, statistical significance, even borderline, seems to make you more likely to be DES rejected. So that's really something I did not expect. But if these results apply to other journals, the conclusions are very important, and it's going to maybe change, I mean, hopeful, wishful thinking, but it could change a bit the norm of people thinking that editors and reviewers are obsessed about statistical significance. Okay, so let me just conclude, and then we can maybe start a conversation answering some of your questions. So there are some problems with the studies. I mean, it's not perfect studies. There are tons of issues, and one of the big one is this is only one journal. So if you look at let's say less prestigious journals, where you find similar results. Well, obviously we cannot answer this question, but one thing I can tell you is the patterns that I just documented. If you look at, say, the 5 top co-editors at JHR that have the highest number of submissions, if you look at those, the distribution is very similar. And here, as I said, in our sample, we have 25. So we seem to have a lot of co-editors. It's one journal, but it's a lot of individuals taking decision, and it seems to be that they more or less all behave in the same way. But also what's interesting is these 25 co-editors are really famous people, really important people in the profession. And I've actually looked at all their resumes, And they've been on editorial boards of lots of journals as associate editors or as co-editors. Actually, they've been co-editor at AR, QGE, JDE, Jolie, like all the journals that you can imagine for an applied microeconomist. They've been there before, during, or after the tenure at JHR. So if these people have a behavior similar at JHR than at these other journals, then the results seems to have a bit of external validity. The other main problem with our survey is, I mean, it's really unclear why authors are withholding non-significant results. I mean, the survey may, give us a bit of an idea if this is happening or not, but we don't really know what's happening prior to submission to JHR. In terms of policies, I think there's a lot that can be done. So I have a paper, for instance, at the Economic Journal that looked at an editorial statement that was implemented by all the journals of health economics. So 8 journals, all the editors agreed, and they put forward an editorial statement for negative results. And thank you. So there's 10 minutes left. It's perfect. Let me just wrap this up and then we can have this Q&A. So these editors at the Journal of Health Economics, all these journals of health economics, they put forward an editorial statement asking health economists to send them papers that do not reject the null hypothesis. And each time you referee a paper for one of these journals, they remind the referee that what they care about is the quality of the study, not whether the results are statistically significant or not. And that's key because you're telling authors, please send us these papers that you were thinking of scrapping. And you remind reviewers that what you care about is the quality of the paper, not whether it's significant or not. And in that paper, in the EJ, what I do is a diff and diff comparing to other journals in other fields. And what you find is a huge increase in number of papers that do not find a significant effect that are published in these journals. So I think it's very easy and not costly at all to change the behavior of people. And I think it's just a question of information. Tell people, write these papers that don't find an effect and submit it to us. And as a field, health economics said, well, we're interested in these studies. I mean, there's also other policies that have been implemented. We have all these registered reports that are starting to be more and more popular in the social sciences. And this is going to affect the behavior of authors, reviewers. So I think there's a lot that can be done. And hopefully our results are kind of pushing in the direction of, look, submit your papers that you didn't find an effect. At least at JHR, that doesn't seem to care overall about whether you found a marginally significant effect or not. So I think, our conclusion in that sense are encouraging, and who knows, maybe they're going to change a bit beliefs about the importance of statistical significance in economics. So definitely looking for your comments, and I think we have 8 minutes left, so let's get to it.